Okay, so our LCD here will be the two factors in the denominator, the 2x plus 3 and the x minus 1. So let's write that down here. So you have 2x plus 3 times the x minus 1. So that means then I'm going to multiply each of the terms by that. So um, I got 2x plus 3 times x minus 1. 2x plus 3 times x minus 1, 2x plus 3 times x minus 1. Okay, again, a lot of times students mess up and they just do it on one side. They multiply the LCD on one side of the equation, and then they forget to multiply it on both sides. Okay. All right, so in this case, the 2x plus 3 are going to cancel, leaving us with negative 4 times x minus 1. The x minus 1 here are going to cancel, leaving us with the 2x plus 3, because 1 times 2x plus 3 is the same thing. And then these factors here are both going to be canceled, leaving us with 1. Okay, and I can just erase this part right here. Okay, so then the next step here is we're going to distribute that negative 4, so that gives us negative 4x plus 4 plus 2x plus 3 equals 1. Then we combine like terms, so negative 4x plus 2x is negative 2x. Sometimes students do the opposite and they're like, oh, I have negative 4x, I'm going to subtract 2x. No, whatever the operation's happening on that side, that's what you do. They're being added, so you add them. Okay, 4 plus 3 will give us 7, right? Anyway, I see that a lot as well. And then now when you're putting it to the other side, that's when you want to do the opposite. So subtract 7, then that cancels there, giving us negative 2x equals negative 6. Then divide both sides by negative 2. Okay, so x will give us 3 again. Okay, so if I plug this back in there, notice that it's not going to make the denominator 0. Okay, so that means that this is going to be our final solution, right? Okay, so I'm actually going to show you two ways to do this. One way is what we've been doing. So, so again, our LCD in this case is 1 plus r. So this would be method 1. Okay, so I'm going to multiply both sides by 1 plus r. Okay, so I have 1 plus r here, times that by 1 plus r here. Okay, so that's going to give us s times 1 plus r, and then the 1 plus r is going to cancel on the right side, leaving us with just a. Okay, our goal is to solve for r, so we're going to distribute the s here. So we have s plus sr equals a. And then we're going to subtract both sides by s. So then s cancels, giving us sr equals a minus s. And then we're going to divide by s. Okay, so then we get this answer here. R is equal to a minus s over s. Now, this is one possible solution, all right? And I would accept this. Maybe the book has a different way of writing it, and I'm actually going to show you 3 ways. Uh, they're all the same answers, okay? So, because I noticed that some of you wrote it a different way, and that's absolutely still correct. So in this case, what I can do is I can divide that s to each term. So I have a over s minus s over s. So that's one possible solution. Another possible solution is You simplify this, so that gives us a over s minus s over s, which is equal to 1. Okay? So you have 3 different possible solutions, and they're all correct. Okay? All right. So you might say, well, I got a different answer. Is that correct? Yeah, if it's one of these 3, you're good. Okay? Another way to solve this is by doing cross multiplication. Okay? So what do I mean by that? So this is method 2. Okay? So we have S is equal to A over 1 plus R, right? Well, remember, S is the same thing as writing it S over 1. They're the same thing, right? I can write it as S is equal to S over 1. So I can rewrite this as S over 1. Then I can just cross multiply. All right, so I'm going to multiply these terms and multiply these terms here. Okay, so that's going to give me S times S plus R equals A. And the process is going to be the same as I did over here. Okay, distributing the S. All right, you get, hold on, I put an S there instead of 1. Let me delete that there, erase that. So that should be a 1. Okay. All right, so again, the process is the same afterwards. S plus SR equals A minus S minus S. So we get SR is A minus S and divide by S. So R is equal to A minus S over S. Okay? So again, 2 different methods, you get the same result, right? Okay, so in this case here, again, our goal here, on the other ones, our goal was to get rid of all the denominator, right? And eventually that's what we're going to be doing here as well. And in this case, we want to solve for y. So our LCD here is going to be those 3 separate variables, right? X, Y, and Z. Okay, so I'm going to multiply each of the terms by that. You have X, Y, Z, X, Y, Z, X, Y, Z. Okay, so each one, again, because my goal is to get rid of the denominator. So when I do that, the first term, the X's are gone. The second term, the Y's are gone. The third term, the Z's are gone. Okay, so then that leaves me with YZ on the left. Then we have XZ plus XY. Okay, so we have YZ, XZ plus XY. And our goal is to get rid of, I'm sorry, our goal is to solve for Y. So notice that we have a Y here and we also have a Y here. So what we want to do is we want to combine those 2 together. Okay? And you'll see what I mean in a second. So I'm going to take this one and move it to the left. Okay. Sometimes it's, all right, here we go. So when I do that, we're going to get YZ minus XY equals XZ. Okay. And then notice that on this side, we have the Y's now, right? So we have this Y and then this Y. So they have that in common, okay? They have that in common. So what we can do is we can factor out the Y. So that would be Y times Z minus X equals XZ. Okay, so I just factored out the Y, I got Z minus X over XZ. Then we just divide both sides by Z minus X. Okay, so then the Z minus X cancels, and then our Y is equal to XZ minus Z minus X. Okay. And that's our answer there. All right. So we're going to do exactly the same thing as the one we were doing. Okay. Okay, so in this case here, our LCD is going to be those three variables. These are three separate variables, R1, R2, and R3. So our LCD is R1, R2, R3. Okay, so I'm going to multiply this by R1, R2, R3, R1, R2, R3, R1, R2, R3. Okay, and then I'm going to start canceling terms. Okay, so again, our goal is to get rid of the denominator. We have our LCD, so it allows us to do that. So the R1s are going to go away on the first term, the R2s are going to go away on the second term, and the R3s are going to go away on the third term. So then we are left with um, R2, R3. This one we will be left with R1, R3, and this one will be left with R1, R2. Okay. So again, our goal is to solve for R2. So notice that our R2s are on both sides. So R2 is here, and then R2 is also here. Okay. So we want to combine those together. So we're going to move that term to the left. So we are going to have R2, R3 minus R1, R3. So basically I'm just subtracting R1, R2 on both sides. Okay, so that's how I'm able to do it. So anytime you want to bring something to the other side, you do the opposite operation. Okay, then we're going to factor. Okay, I messed up somewhere. Okay, let me erase that. So I put a R1, R3, that should have been R1, R2. Okay, because it's R1, R2 when you bring it over. Okay. All right, so we get R2, R3 minus R1, R2. And then again, notice that we have the R2s here. So that means we can factor that out. So we have R2, R3 minus R1 equals R1, R3. Then divide both sides by R3 minus R1, and then R3 minus R1. So that cancels. So then we are left with R2 is equal to R1, R3, and then R3 minus R1. And then that would be our answer there.